Hello, welcome to my channel. We will be solving this exam. You can see it is May, June 2025. Okay, so let's go to the questions. You remember calculator is not allowed in this exam. Okay, yes, so this is the question, first question. It says the diagram shows the graph of a function y equal fx and its absolute value, where f is a cubical polynomial. This is important. Okay, this is the cubical polynomial, and we are seeing the absolute value of it. So the actual graph could be this could come down, I'm just guessing, and then this is down as well. Okay, so when you take the absolute value, this red can come up. Or the other possibility is that it is something like uh, this graph, this is fine, good, and this is the negative side of it. Okay, so you can see that these are the two possibilities. One is this, and the other one, if I show you again here, it is something like this. Okay, so these are the two possibilities of this graph for a polynomial function. Okay, now there are few things. We know that the graph, whatever f of x is, it is passing through -2, -0.5, and 3. Okay, so we can say that f of x, which we need to find out, it is definitely it has this x plus 2 is a factor of it. Okay, in the same way x plus zero point 0.5 is a factor of it, and x minus 3 is a factor of it, right? Now, from these intersection points, we know that these are the factors, but we don't know how much is the expansion in the y direction. So we can say there is a constant k, which we do not know right now. And since there are two possibilities, red and blue, so I will put a plus and minus here. Okay, so using the current information of intersection points, we have this much information. This one is our result so far. Now we know that f of 0 is 2. When x is 0, the value of the function is 2. So I will try to find f of 0. So this is going to be plus minus k, and when x is 0, it is going to be 2 here, x is 0, it's going to be 0.5 here, and x is 0 means minus 3 is here. So this is going to be plus minus, and this cancels, and so okay, sorry, it will become minus plus. It doesn't matter, but just to clarify, just to make everything is precise. Okay, so it is going to be with this minus, it will become minus plus, and then we have a k and 3, right? Okay, and this whole thing we know this is equal to 2. Okay, so from here we can say that k must be equal to plus minus 2 by 3. Okay, so now we can go back to f of x equals this k is plus minus 2 by 3, so we will have again plus minus 2 by 3. So I will like 1 by 3 here, and I will take 2 inside, multiply with this one. So if I leave it x plus 2, and this will become 2x plus 1. Okay, if I multiply 2 with this bracket, and x minus 3. So this is my final answer. Okay, I hope everything is clear, no confusion. Okay, so let's move on to the next question. This is also very easy. So we have to solve this equation. Okay, so x power 1 by 3 is here and x power 1 by 3 is here. So what I will say, I will assume let that x power 1 by 3 is, let me define some other variable y. So this equation will become y plus 1 equals 6 over y. Okay, so if I multiply by y throughout, it will become y square plus y equals 6. So this is easy to solve. I will do y square plus y minus 6 equals 0. And this will become y square minus 3y plus 2y minus 6 equals 0. I hope you know what I'm doing. So from the first two, I will take y common, and from the second two, I will take minus 2 common. Minus 2 plus 2. What did I do? Y minus 2. Yes, I think this is minus 2. Okay. And when sorry, this is plus and this is minus. Yes, that's why I was confused here. Okay, so minus 3y and minus 2y will make 1y. Okay, okay. And then when you take y common, this will become y plus 3. So these are the two factors. So this is giving me two solution, y equal to 2 or minus 3, right? Okay, if now I have two possibilities. Remember y was equal to this thing, right? So it means y equals x power 1 by 3, and this is equal to 2, or y equals x power 1 by 3, and this is equal to minus 3. Okay, so from here, if I raise by power 3, so x is going to do 2 power 3, which is 8. Or similarly, x is equal to minus 3 power 3 is going to be minus 27. Okay, so both of them are correct answer. You substitute any one of them, both of them one by one, put in this equation, and left side is equal to right side. So both of them are the right solution. Okay, so let's move on to question number 3 now. Okay, this is interesting question. We are given the equation of a circle. This is the equation of a circle. Okay, and this is the equation of a straight line. And we have to show that this line is a tangent to this circle. Okay, so there are many possible many alternative solutions to do this one, but the simplest one I think is that try to find the intersection of these two things, intersection of this straight line and this circle. Okay, and if we find only one intersection point, that means it must be a tangent line. Remember what's the definition of a tangent? That the straight line which touches the circle at a single point. Okay. Remember, there are only three possibilities. If I have circle, so the straight line can intersect it at 2 points, or it will not intersect it, or it will intersect it at a single point. So when it is at a single point, it's a tangent line. So let's try to find the intersection point. So I will substitute this equation in this circle, equation of the circle. So I have x squared plus y squared can be written as 2x minus 3 square, and then minus 10x and minus 4y, again y is 2x minus 3, and plus 24 equals 0. Okay, let's expand this thing. So x squared plus, this is going to be 4x squared minus 12x and plus 9 minus 10x minus 8x minus 1 is plus 12 plus 24 equals 0. So this will become 5x squared. Then I have minus 12 and minus 10 and minus 8. So minus 8 and minus 12 become minus 20. So it's become minus 30. Minus 30x. And finally 12, 24 to 36. 36 plus 9, then this is 45 equals 0. If I divide by 5 throughout, it will become x squared minus 6x plus 9 equals 0. And you can see this is a perfect square of x minus 3. Okay, x squared plus 9 and 3 times 2, 6, yes, equals 0. So this is giving you a single solution, x equals 3. Okay, and when I substitute this value of x in this equation of y equals 2 times x, which is 3 minus 3, so this is 6 minus 3, so this is equal to 3 only. Okay, so it means the given that this tangent line touches the circle at point P, so the P is 3 and 3. Okay, So I hope this is clear. It's very interesting. Okay, now the next part, let's find the equation of the circle which has its center at P and passes through the origin. Okay, so remember we have 1, 2, 3, 1, 2, 3. So this is the point P, which is 3, 3. And I need to find the equation for circle which is passing through the center origin, like this one. Okay, so what is this radius? Okay, you can see that this is going to be 3 under root 2. Okay, because we're talking about a right angle triangle isosceles. This is 45, this is 45, this is 3, and this is 3. This is 90. So the hypotenuse has to be 3 under root 2. Okay, now if I want to find the equation of the circle, it is going to be x minus 3 square plus y minus 3 square, and it is equal to the square of the radius, which is 3 times 9 times 2 is 18. So this is the equation of my circle. X minus 3 square plus y minus 3 square. So this is the final answer. Okay, I hope it is clear. Okay, now question number 4. Again, it's very easy. Remember how does sin x look like? It goes from 0 to maximum and then go to 0. So this is pi, right? We need to find this area. In this problem, we need to find this area. Okay, so the integral of sine theta from 0 to pi d theta, remember it's going to be minus cos theta, 0 to pi. Because if we try to differentiate it, then minus, and cos theta derivative is minus sine theta. So this is the final, this is the answer. Okay, so from here, if I take negative common outside and upper limit, it will become cos of pi minus lower limit cos of 0. So I can rearrange it as cos of 0 minus cos of pi. Cos of 0 is 1 minus cos of pi is minus 1. So it is 1 plus 1, 2. Okay, very easy. And this is the next question, part B, that we have to show. Okay, I will solve them. Secant alpha divided by cotangent alpha plus tangent alpha. Okay, so secant is 1 over cos alpha. Okay, cotangent is cos alpha over sine alpha. And tangent is sine alpha over cos alpha. Okay, I will leave the numerator as it is, and I will try to add this fraction in the denominator. So when I add them together, it's going to be sine alpha into cos alpha in the denominator. This will become cos squared alpha. Okay, one cos cancel with cos, and it will become cos over sine. Similarly, the next term will become sine squared alpha, because one sine will cancel with one sine, and sine over cos is over here. Okay, now 1 over cos alpha divided by this sine square plus cos square is 1. 1 over sine alpha into cos alpha. So this is going to be 1 over cos alpha divided by this thing or multiplied by its reciprocal. So it is sine alpha into cos alpha over 1. So cos cancel with cos, and you have sine alpha at the end. Okay, so this is what we had to prove. Okay, I will stop over here. Thank you very much for watching, and I will see you in the next video.